Hello and welcome to this discussion of a project that is being worked on the lower Missouri River. Thanks for taking your time to watch this. Hopefully this will be of interest to you and we can ultimately get your assistance in working through what we're trying to accomplish. My name is Tim Hall. I work for the Iowa DNR. I serve as our Hydrology Resources Coordinator, and I'm heading up this project. This is being done in conjunction with a number of other states. So I'd like to introduce you to the project and let you know how we might get you plugged into what we're trying to do. This project is called the Planning Assistance to the States, or PAS project, on the lower Missouri. So you'll hear that acronym PAS quite a bit, and that's what it refers to. And we're doing this in conjunction with the 4 states of the lower Missouri River, Nebraska, Iowa, Kansas, and Missouri, in conjunction with 2 Corps of Engineers offices, one in Omaha and one in Kansas City. What I want to try to accomplish in this short presentation here for you today is to talk about the details of this PAS project, this PAS study with the Corps. What is it? What are we trying to accomplish? What do we need your involvement for? How can you help us? I want to talk about a specific example problem area just as a way to show you what we're trying to do, and then lay out for you future meeting dates so that you'll know when and where you can actively get involved in the project. Just a quick background. Obviously, those of us who work along the river understand and know this. Historic flooding has occurred on the Missouri River Basin. 4 of the 6 highest runoff years occurred in the last decade. We saw significant flood events in 2010, 2011, 2018, and 2019. So out of 122 years of flow history, 4 of the top 6 have been in the last decade. And the catastrophic results of that flooding has been damage to property, damage to infrastructure, damage to natural resources, fatalities, property loss, just significant challenges resulting from the flooding. Here's a couple of photos near the Fort Calhoun plant in Blair, Nebraska, and in Percival, Iowa, from 2011 and 2019. Just to put some of this historical context in front of us, this is a graph that shows the annual runoff above Sioux City into the Missouri River. So each of those vertical bars is 1 year worth of runoff recorded for that calendar year, starting just prior to 1900 and running through 2019. There are some dashed lines here that run horizontally through the graph. They divide the flow into 10% and 25% intervals. This 50% line right here is the median flow, so that's right in the middle. When you get up here to the 10% line, that means that any flow that's above that line is in the highest 10% recorded history, as well as the 90% line shows the other side. So you can see in the 1930s and 40s, we had runoff numbers that were well below the bottom 10% for flow. So this is the Dust Bowl years of the 30s and 40s, the drought years of the 50s, and then some very dry periods in the 1990s and the early 2000s. On the other end of the spectrum, these blue lines that are sticking up above everything else are times when there's particularly high flow on the river. The upper 10%, any blue line that's above that 10% dashed line is the top 10% of runoff years on the river. So you can see 1993, 2010, 2011, 2018, 2019, very, very significant runoff years in the Missouri River Basin. Including 2011 and 2019, the 2 highest runoff years recorded in the 122 years of data. So why are we doing this now? Well, the 2019 flood provided an opportunity for the 4 states of the lower Missouri River, again, Iowa, Nebraska, Kansas, and Missouri, to get together with the Corps to try to put together a planning project to look at how we might address flooding issues systemically on the lower Missouri River. The Kansas City and Omaha offices of the Corps of Engineers are working with the 4 states. We've been meeting collectively in person before the pandemic and then virtually since then to push this project along. And this is a PAS, Planning Assistance to the States project, where the states and the Corps are partnering in financial resources and staffing for the project. So it's very much a project where the states are in the driver's seat as much as the Corps is. What is the purpose of this study? We want to identify problem areas along the lower Missouri River. We want to identify areas where there's repetitive flooding, where impacts come directly and indirectly from the flooding. After we've identified and created a list of those problem areas, want to develop some conceptual level solutions. How can we not just identify the problem areas, but how can we begin to address solutions to the problems that occur? We're going to use existing data and hydraulic models to work through those problem areas and figure out what solutions might work and what we might be able to do. We also want to use the results of this to allow local, state, and federal agencies to do better floodplain management. All of the information that comes out of this will be made available to local entities, and ultimately to improve future flood risk resiliency along the river. We want communities along the lower Missouri River to be better prepared for the flooding that will ultimately come. Steps of the study. So just real quickly, these are the 3 steps that we're going to work through for the study. We're going to identify and prioritize problem areas along the Missouri River. Create a list of areas where we know there's pinch points or recurring flooding or significant infrastructure loss, excuse me, and then prioritize those, which are most important for us to address first. We want to use, the Corps is going to use existing data and hydraulic modeling to define what the conditions are and how effective those proposed solutions might be, and then ultimately use that data to develop flood risk management plans. Oftentimes you'll hear folks talk about stakeholder involvement. This is a project where we really need the involvement of stakeholders to help us work through particularly this area of the project right here, to identify and prioritize problem areas. We have an idea of where problem areas are. A lot of other state agencies do, but ultimately we need to be working with the stakeholders along the river, local communities, local landowners, ag producers, to figure out and identify where those problem areas are and then prioritize them so we can figure out which ones are most important to work on first. So as an example, this is just an example to get us thinking about what it is we're talking about when we talk about identifying problem areas. This is the area of the Missouri River where the Platte River comes in here from the left. You can see it coming across here horizontally and joining up with the Missouri River that flows from top to bottom in this figure. You can see Plattsmouth, Nebraska on the left, Pacific Junction on the right, Iowa's on the right-hand side of the Missouri River, and Nebraska's on the left-hand side. And here you can see just flagged in yellow areas that were impacted in 2019. The Plattsmouth Bridge was closed. Highway 34 was flooded on both sides of the Missouri River. There was significant Platte River bank erosion on the Nebraska side of the river. All up and down the floodplain on both sides of the river, there was significant flooding impacts. This was due in part to the restricted flow where the Platte River comes in. There's a pinch point where the flowway gets narrow. 2019 was also the highest flow year ever recorded on the Platte River. We've all heard about the bomb cyclone that occurred in central Nebraska. Cold winter, heavy snowpack, rainfall event, warm weather, significant rapid melting and flow into the river. So the flow out of the Platte last year in 2019 was the highest in recorded history. And that caused bank erosion, levee overtopping, breaches, inundated approaches to Highway 34 and Highway 75, and the Plattsmouth River Bridge was also closed. Just as one example of the impacts, there were many impacts just in this location, but on the transportation side, a lot of bridges were closed due to inundated approaches. And Interstate 29 was closed from just north of Omaha all the way down to St. Joseph, Missouri for months during the summer. And for anyone who had to cross the river for work or other purposes, you remember how significant the detours were to get across the Missouri River. So that's just one example of impacts caused by the flooding here at Nebraska City. So that's one example, the Platte River and Plattsmouth and the confluence of those two rivers. But up and down the Missouri River from Sioux City all the way down to southwest Iowa, there are additional problem areas that we know are out there. We want to have you help us identify those problem areas. Pinch points, where is there recurring flooding? Where is the severity of the flooding particularly bad? Where are we vulnerable to impacts to infrastructure, to ag ground, communities? We want to try to make a list of all of those problem areas along the Missouri River. And it's not just enough to identify the problem areas, but we want to try to come up with some ideas of what solutions might look like along those stretches of the river. These are just some very simplistic examples of what solutions might be. So here's an existing condition on the Missouri River. You can see the levee is overtopped and the water extends back into the floodplain, and we've inundated crop ground, roads, buildings, natural resources. This is what it might look like. So what would be some conceptual solutions? Well, we can raise the levee. This would reduce the flood risk locally. One of the things we want to keep in mind is that anytime there's an advantage to someone along the river, there may also be a disadvantage or a challenge to someone else. So we can raise the levee, we can protect the ground behind the levee, but that might increase the flow stage at other places. It also might reduce the access to the floodplain. So capturing both the plus and the minus side will help us evaluate the benefits and usefulness of solutions we come up with. We could set the levee back, again, similar advantages, similar challenges. This is another possible solution. Could widen the channel, particularly in areas where there may be pinch points. We could widen the channel. There are advantages to decreasing flood risk, but there's also some significant costs. There has to be potentially some real estate land acquisition for widening. So there's a downside to this solution. It might be a good one, it might not. We'll have to work through that. We could raise buildings. We could put buildings up on pads. We could elevate them to get them out of the floodplain. That can be done. That's expensive, but it certainly is a potential solution. We could relocate buildings altogether, get everything out of the floodplain, and just relocate that. There are other solutions too. I mean, this is just a quick list of what the solutions might be, but there's off-channel detention. There may be some issues that we can deal with up in the watersheds. We might be able to raise roadways up to provide protection for infrastructure. So we want to go through for each problem area and talk about what the specific solutions might be for that area. We're going to develop a matrix. We're going to go through and look at these areas for each of the problem locations that we determine. Apologize, there's a lot of words in this slide, but I just want to hit the basics. You can look at this at your leisure. We want to define the area that we're talking about. We want to identify site characteristics. You know, what are the problem features in those areas? We want to list potential solutions. What's a potential solution for the site we have? And then we want to go through and look at advantages and challenges for each of those solutions. So for each problem area, we're going to develop this sort of list, and we're going to put it in a matrix that looks like this. This again is an example of the solution matrix for the Platte River confluence. This is just intended to be an illustration for what this might look like. So this is not the potential solutions. This is, again, just a way to get us thinking. So here are the areas we just talked about: area, site characteristics, potential solution, advantages, challenges. And you can see this matrix has been filled in for different solutions. So here's a levee raise solution. The advantages are increased level of local protection. The challenges that exist and might cause some stage impacts regionally. It's going to increase the levee footprint, require some real estate. So there are advantages and disadvantages to this solution. What we want to do, though, is think about this type of a matrix, and we want to generate a table like this for each problem area. So if we go through together, stakeholders, state agencies, the DNR, and identify 40 problem areas along the Missouri River, we'll develop a table like this for each one of those problem areas. That'll be then combined with information from the other states to give us a comprehensive look at the lower Missouri River. So what is it how are we going to do this? In July, next month, we don't have the dates set, but we're going to be working on those here pretty shortly. We want to conduct some virtual stakeholder meetings. Using this introductory information, we then want to sit down with stakeholders virtually and talk about problem areas. Which areas can we identify? Let's talk about where they are. Let's make sure we know where they are on a map. Let's start to look at a solution matrix for each one. What do you think the possible solutions might be? Is there other relevant information that we can gather from stakeholders, from you folks who live and interact with the river on a daily basis? And then we're going to want to talk about how we might prioritize problem areas. If we have 40 problem areas, we might be able to develop solutions and have the core work on solutions for 10 of those. Well, how do we figure out which 10 we want to address first? So we're going to have to talk about prioritization. We're going to hold multiple meetings, probably 3 or 4 virtual meetings over the span of a couple of weeks, where everyone will be allowed to or able to provide input, engage in an actual discussion back and forth as best as we can online to collect all that information. We're then hoping to, and this is tentative, but we're hoping in late August to pull together some in-person stakeholder meetings along various locations of the river. The reason we want to do in-person meetings is we want to have a real face-to-face discussion of some of the things that we gathered in the virtual meetings and sort of hash out what the solutions might be. We're considering the possibility of having at least one of those meetings be a joint meeting with our colleagues from Nebraska and stakeholders from Nebraska, since what we do on our side of the river affects their side of the river and vice versa. We want to try to see if we can put together a meeting where we can all gather together and discuss river issues together. We want to develop a set of criteria for how we would prioritize those problem areas. How would we rank those? And see if there's additional information that we can glean for problem areas. The outcome for these in-person stakeholder meetings will be a list of prioritized problem areas, and along with a solution matrix for each one. And each of the states, each of the 4 states of the lower Missouri will be doing the same process for their sections of the river with their stakeholders. And then we'll present those to the Corps. We'll have a discussion with the Corps of Engineers about how what we found out, and then they'll take those and use those further in the project. So future announcements and schedule. As I said, we don't have the date set for those virtual meetings, but we intend to get those set up fairly quickly. That will be advertised in the Eco Newswire, which comes out each Thursday from the DNR. We'll also put those on the DNR website. We have a page called SIMRA, the State Interagency Missouri River Authority page. So that seems like a logical place to put Missouri River information. So you can go there and find information on the next steps of this process. And my contact information is listed here at the bottom. Feel free to drop me an email, and I'll make sure that you stay informed of what the future progress is for this project. If you have questions or comments, you can certainly email them to me. You can collect those and bring those to virtual meetings in July. You can bring those questions or comments in August to in-person meetings if we're able to have those. But I can't stress enough that the success of this project depends on your participation in what we're trying to accomplish. We need to get from stakeholders an active engagement in helping us understand the problem areas and potential solutions along the river. So I look forward to the chance to meet with you in the months to come. So again, thank you for your time. Thank you for spending a few minutes listening to this. You can go to the website, find this video. You can find the PowerPoint that I've presented here, as well as other information that, as it becomes available, will be put on that website for you. So look forward to the opportunity to continue to work with you on this project, and look forward to your involvement. And if you have any questions or comments, please reach out to me and I'll be happy to work with you on that. So thanks very much. Appreciate having you here today, and we'll look forward to seeing you down the road. Thank you.